All right, recording has started. And when you're in Discord, right at the beginning of class, when you first get in, it's probably a good idea to click on voice channels general, to join the voice channel. And then when I go live, you'll hear my voice immediately. All right, we're going to go back. We had done this practice quiz. Oh, and by the way, Comcast had done a little work, so I could use a little feedback today on how the session is going and if it's broken up again, to see the effect of what Comcast did on my system. So we had done problem number 1 last time, so I erased my results. So I want you to do it again, because this stuff needs to be reinforced, and I want to really make sure you get this for the transformations of functions. So let me give you a minute to do number 1, all the different parts. Hearing some input from somebody. Perhaps it's Beverly. If you could mute your microphone. Beverly, thank you. Let me just check how many are here. 19, okay. So 30 seconds more. Okay, so h of x shifted 3 units to the right, just like last time. I'm going to do this one first. Shifting down is easier. That takes everything, pulls it down. When you go left or right, you have to replace the x. So I think of this as f of x equals x squared. And I'm going to replace the x with x something squared. Now, if I did a plus 2, it would move it to the left 2, because this goes in the opposite direction. So I put a minus 3. That moves me 3 units in the opposite direction of that, to the right. And this makes sense as well, because when we graph this thing, x minus 3 squared is a parabola just like this one. You can never get x minus 3 squared to be negative, because when you square something, you always get 0 or positive. You'll only get the smallest number. You only get 0 when x is 3. When x is 3, the h will be 0. h of 3 is 0. And all the others will be positive values. Reflected across the x-axis, we put a negative sign. All the heights will be negative instead of positive, and we'll send it down like this. And vertically stretched by a factor of 4. that takes the normal parabola that would have been like this, and instead makes it go 4 times as fast vertically. So it's vertically up higher. It still goes down to the origin. I didn't make that graph very good. Because when you make 4 times the height of 0, you still have a height of 0. Alright, if y'all can give me feedback on this now. Nailed it. If don't hit enter quite yet, but nailed it if you got it. Still working on it. And tell me what's the hardest part for you. Which A through D is the most difficult for you. Okay, and go ahead and hit enter. Alright, let's do 2 again as well. We did this last time, but I'm going to have you do it again. Thirty seconds more. Okay, h of x is the same as this, but it's vertically stretched by a factor of 2. So that will do it. Shifted left 5. To shift it to the left 5, I replace x with x plus 5. And it shifts it horizontally in the opposite direction of that sign. And up 1 will go like this. And so that's the equation of it, but the graph y equals x squared to x is a sideways parabola, the upper half of a sideways parabola. The thing, we're going to move it to the right 1, no, left 5. So if this was 1 and this was 1, like this, and by the time you got maybe over 4, you're only up 2. Because you're the square root of that. And then we're going to shift this whole thing. This point is going to go to the left 5, so way over to negative 5. And it's going to go up 1, so that's going to be my new starting point. This starting point got moved over to here. And then it's going to vertically stretch by a factor of 2, so it's going to rise faster. It's a parabola stretching to the right, but moving over like this. Alright. Type in some feedback on number 2. Nailed it? Or which part is more difficult? okay with making the equation, the graph's tougher, or whatever. We're still working on it. Type it up, but don't hit enter yet. This lets me know if I need to keep reviewing this, or we can just move right on. Okay, let me know. Go ahead and hit enter. All right, and I see a comment, breaky and frozen. Let me know if you're having a bad connection, if it's breaking up a lot or not. So just brief comment on the connection itself. Is it going good, or okay. All right, that's nice to see. For most, it's going good. All right, now let's go to number 3. Solve this equation. I'll give you a minute on this. Okay, 30 seconds more. All right, let me have you stop. Now, let me tell you, in the history of math, this is Robert's imagined history. It's not the way it really happened, but it could have happened this way. Is that there were functions without x squared in it. If the x squared is missing, we call these linear functions. And they had a system developed to solve linear functions. You know, divide both sides by -3 and you'd get the x by itself. And as soon as they came up with x squared along with x in the same equation, now these happened a lot. There are really common equations for all kinds of applications. But I'm imagining that math ground to a halt then. And I'm imagining some of the things they tried to do. Like one of them said, all right, I'm going to solve for x, so I'm just going to divide both sides by -3. And then this side becomes x, and this becomes this. And then they said, done. And this kind of being done, though, is like looking up the word boondoggle in a dictionary and finding that it says, well, a boondoggle is a boondoggle with wings. You can't use the word itself in its definition. And so you're defining x in terms of x. That doesn't tell you what x is. So this might have been one of the early attempts, but not legitimate. They might have tried to, all the techniques for isolating x. Maybe they subtracted 2, and they got x squared equals -3x minus 2, and then tried to take the square root of both sides. But before even doing that, they would have said, no, that would give me the same problem over here. X in terms of X. So everything they tried was a dead end. They might have tried something like this. Moving this minus 3x to this side by adding 3x. Add 3x to both sides. Subtracting 2 from both sides. And then getting x squared plus 3x is equal to negative 2. And then say, well, at least we got all the x's on one side. And then they said, well, maybe we can factor out the x. But you still can't get the x all by itself. And so they got stuck. None of these methods would work. Until finally, one day, this new approach was taken. And what was the breakthrough was this idea. Let me get my drawing thing to work right. Breakthrough. If two numbers multiply to be 0, then the only way that can happen is if A is 0 or B is 0. If you multiply like trying to get 0 and you multiply a number in its opposite, like 3 times negative 3, you get negative 9, you don't get 0. The only way two numbers can multiply to be 0 is if one of them is 0. And so that was applied to this problem up here. We moved the 3x to the left-hand side. Okay, once we move it to the left-hand side, then we rewrite this as a multiplication problem. That's exactly what factoring is. Right now it's an addition problem. 3 terms are being added together. When you rewrite it like this is called factoring. And then two numbers that multiply together to be 2, do the signs first, and then two numbers multiply together to be 2, 2 and 1, and then the two middle terms will give you what? 2x plus 1x is 3x. That gives you the correct middle term. Now you have this idea, a times b equals 0. Then either this one is 0 or this one is 0. To get an a is the whole thing, x plus 2. And the only way x plus 2 is going to be 0 is if x is negative 2. And the only way the other one's going to be 0 if x is negative 1. Alright. You're going to get two solutions for this. And if we check them, I'll go way back. And check. X equals negative 2. I'm going to get 4 plus 2 and on the left. And I'm going to ask, does that equal to negative 3 times negative 2? And yes, they both give you 6. And the same thing with negative 1. If I plug in that, I get 1 plus 2. Does that equal negative 3 times negative 1? And yes, that gives you the correct answer. Alright, so give me a little feedback on this. Nailed it, and or still working on it, and if the explanation I gave you added insight, let me know. If you kind of already knew this and I was kind of wasting my time, that's good for me to know as well. Kind of doing this imagined history. Was that the add inside or not? Okay, type that up and then go ahead and hit enter. Okay. Confused where the square went. Alright, let's go back and look. The square kind of gets hidden in here. If you FOIL all this out, well, let me erase this stuff. If I FOIL this out, x times x is x squared, x times 1 is plus 1, 2 times 1 is plus 2, or plus 1x. 2 times 1, x is 2x plus 2. And then this is the same thing, x squared plus 3x plus 2. This right here means the same thing as this, but the x squared is kind of hidden in here now. But then we can see two things multiplied together is 0. One of them has to be 0. Alright. Number 4. Find the equation of the line that passes through those 2 points. Okay, 30 seconds more. Okay, let me have you stop. This one, if you remembered, y equals mx plus b, you kind of have a starting point. You kind of need a starting point for an equation of a line. And that's the slope, that's the y-intercept. And if we have the graph of what's going on here, 0, 2 is right here, and 1, 2, 3, 4, 5, 1 is right here. And so this is the line going through those 2 points. And, oh geez, there is the y-intercept. And the slope is the difference in the y's, and the difference in the x's. Okay, so, and that makes sense when we look at the picture. If you go from this point to this point, you have to go down 1, and then to the right 5. And so, y equals negative 1/5 x plus 2 is the equation of the line that passes through these 2 points. Now, I can prove that that's the case. Let's check. This is also a function. And if you plug in this input, you better get that output. If you plug in 0, you're going to get negative 1/5 times 0 plus 2, which is 2, which checks. And if you plug in 5, you better get 1. Negative 1/5 times 5 plus 2. Well, that's negative 1 plus 5 is 1, and that checks as well. All right, give me a little feedback on equation of the line. Type it up, but don't hit enter quite yet. Okay, go ahead and hit enter. All right, questions on anything? And you can type in questions or you can just speak up. All right, if there are no questions, and we're going to continue on with inverse functions. Let me check over here. 3.5 homework and worksheet are still due tonight. Let me look at my schedule. Today is Thursday the 1st. Yes, that is correct. Transformation of functions and the compositions, that stuff is due tonight. Alright, so let me review what we had gone over on inverse functions. We started with inverse actions, like opening a window, closing a window, climbing up a ladder, climbing down a ladder, and the whole point is when you do an action followed by its inverse action, it totally undoes the action, so as if nothing had ever happened. And we found out something tricky though, when you had two things together. Entering a room and turning off the light, and turning on the light. You couldn't just negate each one. You had to also reverse the order. We had to turn off the light first and then exit the room. If you exit the room first, you can't even perhaps even reach the light switch. All right, and when you had multiple things, you had to reverse or take the inverse of every action. But you also had to start with what was the last one, make that the first, and reverse the order. Okay. And we had done inverse described verbally, adding 2 to x. So x is what you're starting with. Now, when we say add 2 to x, let me kind of get a little bit of a picture to kind of show you this as well. One of my favorite images for functions is what we call a function machine. And it's another way to visualize what happens in a function. And suppose it's this function, that's number 1, which is add 2 to x. What comes in is any number x. And there's only one thing that's going to happen to it. You're going to add 2 to it. And then what comes out is x plus 2. So if 10 went in, 12 comes out. So something was happening to the x. And that's why we had to do this thing. We couldn't say subtract x from 2. We had to say the from had to be with x. Subtract 2 from x. Start with x, subtract it from. And then multiply x by 5. It's important the order of this. Divide x by 5. We have to start with x and have something else happen to it. Alright, and then this is where we ended last time. Subtract 2 from x and multiply the result by 3. We had started by just taking subtract 2 from x and make it to add 2 from x. And multiply the result by 3 and divide the result by 3. And that's the first thing I would have done too, but then we realized, we also have to reverse the order. Divide by 3 and then add 2 to the result. So invert each action and reverse the order. All right, now we're to writing functions and inverses symbolically. So express the statement and its inverse symbolically. So now here we introduce the new notation. F, and it looks like a -1 exponent. And it doesn't mean -1 exponent. When it's on a function, and this is the strange thing with math, we sometimes use the same symbol in different contexts and it means something different. Let me just a quick review of negative exponents. 5 to the -1 power. I'm going to ask you, does this equal -5? And anybody can comment. Is this correct? Is 5 to the -1 equal -5, or should it be something different?
It's incorrect.
Incorrect? All right, what is correct?
I believe it's supposed to be 1/5 or
That
1
is
over 5.
exactly right. Five to the -1 is you bring every negative exponent to the other side of the fraction and change the exponent to being positive. And then there's really anything is itself times 1, so there's really a 1 up there. So the answer is 1/5. Negative exponents get you fractions. Now this f to the -1 does not mean f to the -1, and we don't read it as f to the -1. We read this as f inverse. Inverse. Not f to the -1 power. It doesn't mean reciprocate it, bring it down to the denominator. That's what we wound up doing for 5 to the -1. Bring it, it doesn't mean that. It means the inverse function. Now, inverse function is what we've been talking about here when I've been saying, right, describe the inverse of the statement. Add 2 to x, the inverse of that is subtract 2 from x. It's the inverse of addition is subtraction. The inverse of multiplication is division. It's what undoes the other things, kind of the opposite in terms of operations. All right, so your job on number 1, and I want you to go to your group chat and type in your answers for this. And do number 1, write symbolically what goes in the right hand side for both of these, and type it up, but don't hit enter quite yet. Okay, go ahead and hit enter. And let me ask group 3, what did you get for this one? F of x is equal to what? Group 3, and I'll check over here if mic is not working. Got anybody in group 3? Are you here today? Maria or Addison, either one of you? Okay, let me go to group 2. What do you got, group 2? Nothing from group? Yes.
Yeah, so we got f of x equals x minus 3.
Are you doing number 1 here? It says add 2 to x.
Yeah, wait, no, I don't think that's is it. Wait, is it f of x equals x plus 2 over 3?
No, just simpler. Just with the first part, there's x plus 2. The function is just adding 2 to x, and that's all.
Oh, okay.
Okay, that over 3 stuff was for a different function. That was the example.
Oh, okay.
Okay, so if this is the function, what's the inverse function?
It'd be x plus 1/2.
Very interesting. Yes. All right, now that gives us a chance to check it out. Let's check. And I'm going to say f of 10. When you do add 2 to x, f of 10 is 12. Because we added 2 to x. Now, if I do f of 12, it should be the inverse function, so it should take the 12 back to the 10. But if I add 1/2, I get 12.5. It kind of doesn't really undo the adding the 2 over here. We need something that undoes adding the 2. And so if we go up here, the verbal description, subtract 2 from x, is what we want. So let's come over to here. Let's go to subtract the 2 from the x. So then f of 12 would get me back to, if I put 12 in here, 12 minus 2 is 10. Whatever I did here, it completely got undone. Back to 10 as if nothing had ever happened. When, oh no, this isn't f of 12, this is f with a minus 1. F inverse. F inverse of 12. Okay. So let me get a little more space in between these things, so I don't run into the space problem again this next time. All right. So, your name was in group 2? Who was that was talking? Was that Tony? Anyway, thank you for your contribution. That was moving us in the right direction. And 1/2 was a pretty reasonable thing to do, because it was like, just flip this guy over, maybe that's it. But we refined that and we got this. All right, let me have you do number 2 now. So go ahead. If the function is multiplying x by 5, write it symbolically and then write the inverse symbolically. Okay, go ahead and enter that in your group chat. Okay, group 1. What do you have for this one?
This is Brianna from group 1.
Okay.
Would the first one be, so the first one would be just multiply by 5, correct? And then the inverse.
So what do I write for next to f of x?
So
F of x
just multiply
equals
times 5?
just a 5?
Yes.
All right. Now, if you don't put an x in there, then what this means is this function is always 5 no matter what the input is. If we put an x right next to the 5, then it means f of, like say if the x was 2, would be 5 times 2. So if we're going to multiply by 5, we need to have a multiplication sign, and we're going to need that. What are we going to multiply by? By whatever that input was. So we'll put 5 times x. All right. I'm glad that you were guessing just 5, because I think that's a kind of a pretty instinctive reaction here. And it shows that we need this extra x as well. All right. So what about f inverse of x? Brianna?
Would that be f divided by, 5 divided by x? Or x divided by 5?
Ah, which one?
X divided by 5?
Very good. And that jives with what we'd written before. Divide the x by 5 instead of the 5 by the x. And let me show you why it had to be this way. Let's come back. Suppose we had done f of 2. According to this rule, f of 2 is going to be 10. Now f inverse should exactly undo what we did. So if we take the 10, it should get us back to 2. But if we do 5 divided by 10, that isn't it. We'd get 5/10 or 1/2. But if we did 10 divided by 5, we get 2, which checks. So again, it's kind of like, remember, a function is like, could be an action like opening a window. And then the inverse function would be closing the window. So if you do one followed by the other, it completely undoes. So if we take a 2 as the input and get a 10, the inverse should take the 10 and bring it back to 2. It just is exactly. This one we can think of it as, the function can be thought of in so many strange ways. But one way could be, it takes a pile of money and makes it 5 times as big. And the other function, what's got to be the inverse of that? It would take a pile of money and makes it 5 times as small. So you'd love this first function, you'd hate the second one if it was your own money that you were investing. But how they are going to work with each other is that completely, if you do one and then the other. If you took $2, invested it, and it became $10. And then you took it into the second function, took your $10, invested it, you'd be back to the 2. If you did both of them, it's as if nothing had ever happened. All right. So now we get to a harder one. Subtract 2 from x and multiply the result by 3. You got to write out what your f of x is and what your inverse function is. I'll give you a minute for that. Type it up into your group chat. Don't hit enter quite yet. Let me see how many groups we have in this class. We have 6 groups. Go ahead and hit enter. See what your group mates are trying as well. Okay, group 5. You can always say pass, but what did you get, group 5?
One second.
Uh-huh. All right. You can go ahead and pass or give me any kind of a stab at all. Group 5.
For the first one, it would be 3 times x minus 2, and then the inverse would be x
Like
divided
this?
by... No, the 2 and the 3 would, the x and the 2 would be in parentheses.
Okay.
And then the other one would be x divided by 3 plus 2.
Okay. We're going to check this after a break. And we'll see if I agree totally with your f. I'm not sure if f inverse is correct or not. It seems to make sense, but I'd have to check it out to see if it's really the correct inverse. And we'll do that when we come back. So we'll start again. At 1:35. Anybody need to talk to me for anything? Check in or anything like that?
Will we be able, this is Brianna,
Hi.
will we be able to ask you questions about the homework, on the next part?
Which homework are you talking about?
3.7.
Yes. Are you talking about like Tuesday? After our,
No, on the next half of this class?
to answer 3.7 questions? I'm going to have you hold those questions until Tuesday, because I want to make sure that I get through everything with 3.7. And then if we have time at the end of class, I can get to those. But if we don't, then I'll have you ask those on Tuesday. Okay?
Okay, thank you. And I also have another question, but about my submissions, but can I ask you that after class?
You bet. I'll hang after. Remind me. I might forget.
Okay, thank you.
Okay. Anybody else need to talk to me about anything?
I have a question.
Yeah.
So for 3.5, are we still gonna have to turn it the same day, correct? Because
Yes.
we had a spot check on it, but we didn't really get to do much with it.
Oh, do you have
'Cause we're still
questions
learning
on
it
3.
today.
Do you have questions on 3.5 that you want to ask?
Because I'm still kind of confused on 3.5. Is it? Or maybe it's 3.7. I'm sorry. So, because we had a spot check on it, and we didn't really get to do a lot because you're still teaching it right now.
That's right. 3.7 is not due today.
Okay.
It's due a week from today.
Okay. Thank
Okay?
you.
You're welcome. Anybody else with a question? start back up again. And so we need to look at this to see if this is really the right inverse function. There's more than one action happening. And so we had to kind of reverse the order. Did this reverse the order correct or not? Well, one way to find out is to just see if, let's take f of 1. Well, actually f of, let's say, 5. And see what we would get. You would subtract 2 from the 5 to get 3. So it would be 3 times 3, and it would be 9. Now, f inverse of 9 should give me 5. Divide by 3, and I would get 3. And then 3 plus 2 is 5. Wow, it works. So, yes, this is the right inverse. Now, notice over here, when we were substituting 5 in for f, first thing we had to do was subtract 2. And then the last thing we had to do was multiply by 3. Over here, the last thing became the first. Divided by 3 instead of multiplying by 3. And then the first thing became the last. Instead of subtracting 2, we added 2. So everything was done in just the right order. Now, this way of verifying, though, let's kind of formalize this. Verify that a function and its inverse really do undo one another. First, do this with an input.
I have a question.
Yes.
So I'm confused. Where did you get 9 from? Or like, where is this f of 5
Okay.
equal?
This 5 went in right here. So I got 5 minus 2, which is 3. 3 times 3, the 9. Does that answer your question? And the 9 went in here. Give me 3. 9 divided by 3 is 3 plus 2, giving me 5. Okay. So, any other questions? All right. All right. So we have an example here for the function. Here's the two functions. Let me space them a little bit. If the first function is dividing by 3, so if you invest in this scheme, you would lose money. You will only have 1/3 of what you started with. And the inverse then would be making your pile of money become 3 times as big. To see if these are really inverse functions, if we took f of 7, now look at f inverse of f of 7. F inverse of, now we took 7, f of 7 made the 7 3 times as small, and so you got 7/3. The inverse function made it 3 times as big, so you multiplied by 3 and you're back to 7. And what happens, it's as if the inverse and the original kill each other off. Because they're opposites, it's like climbing up a ladder, climbing down a ladder, and you get back to 7. And okay, and even if we do this with a variable x, for the function f of x is x divided by 3, replace the f of x with x divided by 3, and then the inverse of that is 3 times that, and then the 3's cancel out and you get back to x, and once again, it's as if these two things kill each other off. And then you're just left with x. Let me kill them off a little better. That and that. Okay. F and F inverse cancel each other out like this. Alright, so we're going to practice this. The function is adding 2 to x. I want you to write the f of x, the f inverse of x. And I want you to do f inverse of f of 7, and then f inverse of f of x. So, let me give you a minute to do number 1. And as you get answers, I want you to type them in to your group chat. And you can type them in right away. As soon as you come up with f of x, f inverse of x, so on. Okay, let me go over these answers. The function of adding 2 to x is this. The inverse function is subtracting 2 from x. And if I did f inverse, now f of 7, I need to actually do it. But f of 7 is you add 2 to 7 and you get 9. F inverse of 9 is you subtract 2 from 9 and you get 7. And it did work, just like these two things killing each other off, and that checks. Okay, and then we're going to do it again with just plain old x's. Let me give you a minute to do part B. I'll give you a quick 30 seconds. Alright, so this one is f inverse. Replace f of x with x plus 2, because that's what f of x is. Now, f inverse of x plus 2 means whatever the input is. Now that came in all at once. So I'm putting pretend parentheses. Then we subtract 2. But the 2's kill each other off, and you do get x. Once again, it's as if these two kill each other off, and you're just left with the x. Exactly undoes what the other one did. Alright. So, I kind of led you through that one. I'm going to have you do this next one, and then I'm going to call on a group. So, number 2, work on your own for a bit. When I tell you, you can hit enter with your group chat. ahead and hit enter. Okay, group 6. What do you have for f of x?
For f of x, we have 5x.
And inverse f? F inverse of x, what do you have?
X over 5.
Great. And what do you have for f inverse of f of 7? What should I write down?
We have f of 7 is 35.
F of 7 is 35, so I'm going to replace this f of 7 with 35. So I still have f inverse of 35. And what is f inverse of 35?
7.
It's 7. And it did work. The f and the f inverse killed each other off just like they were supposed to. And what about for f inverse of f of x? What do you have?
We have the f inverse, or wait, sorry. The f, f inverse is 5x.
F inverse of 5x. We'll put the word of in there. Okay. Keep going.
And then that would just be the x.
Because you divide that, you get 5x divided by 5, which just gives you x. And it's as if these guys canceled each other out, and you just got the x. It verifies that they are indeed inverses of one another. Thank you very much. All right. Now, inverses of simple functions. What I want you to do is fill in the right-hand side of each one of these with the correct inverse function. So, let me give you a minute. Just kind of go as quick as you can. Just use your intuition. We've already done some of these, but some of them are new. All right, let me have you stop. So, this is multiplying a number by 5, making it 5 times as big. You know, I told you like pile of money. You bring in a pile of money and it becomes 5 times as big. You can also think of it as some kind of machine. You have a length of Play-Doh as your input, and it's going to stretch it out and make it 5 times as long. Something like this. It has all kinds of different visualizations. But the inverse is making it 5 times as small. The inverse of adding 2 is subtracting 2. The inverse of cubing something is cube rooting. Come on. When I make it too small, it thinks I'm doing something else. The inverse of dividing by 4 is multiplying by 4. If it was, you know, making the length of Play-Doh 1/4 as long, and then you'd have to make it 4 times as long to be the opposite. And if it doesn't do anything, then the inverse also doesn't do anything. The output's the same as the input. All right. Any questions at this point? Is it feeling somewhat intuitive? At this point, before I jump into this last part, I'd like to see just some general feedback. If everybody could just say it's all making sense, or you're going a little too fast, or whatever the feedback is, go ahead and type something in. And you can go ahead and hit enter. Sasha, can you tell me a little bit more about where you're confused so I know what to review?
I got confused on where f of negative f of x and like the top problems. It says multiply by 5 and then 5x, like that I get, but then I didn't get the a and then the f negative 1 and then f times 7. Does that make
Back in here when we were doing
Yeah.
sevens.
like, yeah, I get like the basic ones, but I didn't get the like f of 1 times 9 and 5. That's where I got confused.
Okay. All right. I'm going to keep going on, but that gives me an idea of how I want to structure some practice quizzes to emphasize certain things, and I'll try to review some of that too a little bit later. Thank you for the input. All right. Now, let's go to a foolproof procedure. The function f of x equals 4x cubed minus 3 has three operations that happen to an input. The input gets raised to the third power, then it gets multiplied by 4, and then has 3 subtracted from it. Our foolproof procedure for generating the inverse function, f inverse of x, must invert every operation, like changing multiplying by 4 to dividing by 4. Reverse the order of these operations. And I claim that the 3 steps below is a foolproof procedure, and it will force, number 1, it'll invert every operation, and it'll force number 2, it'll reverse the order of the operations. And the steps that you have to follow, now that's one note, always, let me bold this, it kind of reformats my stuff on its own. That shouldn't have been indented. The steps that you're going to do are, number 1, interchange x and y. And you may have to replace f of x with y before you do this. Then you're going to solve for y, and then we replace y with f inverse of x. If we do these 3 steps, it will lead us to the inverse function. So we'll follow these 3 steps with 4x cubed minus 3. So the first step. The first step says interchange x and y. So I, first of all, unwritten step was replace f of x with y. And then to interchange x and y means every time there's a y, write an x. And every time there's an x, write a y. So that's what I did to come up with this. X equals 4y cubed minus 3. And there's a little statement here. It says, notice that first x is raised to the third power. Like if I told you x is 10, how would you find f of x? You'd first raise 10 to the third power, then you'd multiply by 4, and then subtract 3. So the first thing you're doing is raising the third power, and the last thing you're doing is subtracting 3. Now, the next step is solve for y. We take this equation right here, and we solve for y. To solve that equation for y, first thing we do is we add 3 to both sides. Now I add 3 to both sides. Notice the last step in the original was subtracting 3, and that had to get resolved first right here, adding 3 to both sides. We're reversing not only each operation, but we're also reversing the order when we solve this for y. So I added 3 to both sides. And then I come up with x plus 3 is 4y cubed. Notice that subtracting 3 has been changed to adding 3, and this now comes first. Now, the next thing is I'm going to divide both sides by 4, and I'm going to turn this around and put 4y cubed equals x plus 3. And again, I'm doing step 2, which is solve for y. But I can't get rid of this cubed without getting rid of this 4 first. So the next thing will be I'll divide by 4. And I get y cubed x plus 3 divided by 4. Now, remember back up here, the first thing, if x was 10, the first thing you had to do was raise it to the third power, then multiply by 4, then subtract 3. Okay, and I'm dividing by 4, but that's kind of the second step. First one was adding 3, second was dividing by 4. Now, if I'm further to solve this for y, I've got to get rid of the cube. To get rid of a cube, you do the cube root. But if you do that to one side, you have to do that to both sides. Now, anything cubed and cube rooted, those kill each other off. You just get y. We get this. Now, three-step process was interchange x and y. We did that. Solve for y, we just completed that, and then replace y with f inverse of x. So, if I replace this y with f inverse of x, I get this equation down here. That's my inverse function. And this inverse function is, make it a little smaller so I can see the original function. Here's the original function, here's the inverse function. The first thing, if I told you x was 10, the first thing you'd have to do is take 10 to the third power. The last thing you do over here would be take the cube root. So it not only inverted every operation, but it inverted the order. It did it all kind of automatically. Just following these 3 steps really simplifies the process of finding the inverse function. All right. Now, once you find the inverse function, you can also verify that it's an inverse function. But I'm going to have you, something in here on top of each other. So. Yeah, that's the problem with this one note. It's kind of okay. So we're going to look at, my OneNote stuff is kind of screwed up. Practice for each problem, find f inverse. Suppose f of x is this one, 2x minus 1 cubed. Alright, so it's a bit different than this one over here. And we're going to find f inverse. And this is the stuff that I don't need. All right. So, step 1. Now, there's an unwritten step. Replace this with y. Then I want you to go through these 3 steps. Interchange x and y in this. And then solve for y. And then replace y with f inverse of x. So, let me give you a minute to practice what we just saw and to find f inverse. And then I'll do it in just a minute as well. I'm going to give you 30 seconds more. Just get as far as you can. So, step 1. Interchange x and y. And this part, let me just, oops, too much. Okay. So I'm going to interchange x and y. So every time I see a y, I put an x. Every time I see an x, I put a y. Step 2. Solve for y. So now I'm going to take this equation. Well, the thing I'm solving for, I'm a little more comfortable if it's over on the left side. I'm just going to turn this around. Now, I can't get rid of that 1 or that 3 first until I get rid of this 2. So I'm going to divide both sides by 2. Then I can't get rid of this minus 1 because it's inside of parentheses. So I have to get rid of that 3 first, the cubing. So I'm going to take the cube root. Of both sides. Now this and this kill each other off. And then I'm going to add 1 to both sides. And I get y equals the cube root of x over 2 plus 1. The very last step is number 3. Replace y with f inverse of x. And if I do that, I get f inverse of x is this. Alright, so the original function, I'm going to shrink it a bit so I can see both. Alright. That's too small to see. But the original function, let me just go back and forth. Multiplying by 2 was going to be the last thing. Like if I told you x was 10, first thing you have to do is subtract 1, then raise to the third, and multiply by 2. Notice multiplying by 2 is the very last thing. And over here, dividing by 2 is the very first thing. If I told you to find f inverse of 15, first thing you do is divide by 2. And then you take the cube root and so on. So it inverts every operation and inverted the order. Alright. Now, similarities and differences between f of x and f inverse when we look at tables. Alright. When we look at a table of values, let me give you a very simple example. Suppose f of x is 3x. And if I made a table of values, it would look like this. 1, 2, 3 would become 3, 6, 9. The inverse function is x divided by 3. What's really cool about this is that it takes, if you just take exactly what you have over here, but put the input column into the output column, put the output column into the input column, or just flip every single one of these pairs. 1, 3 becomes 3, 1. 2, 6 becomes 6, 2, so on. This is how a function and its inverse always relate to each other. The table for the inverse function is exactly, can become exactly the same as the table for the original function, but just flipping the two. It's all you do. Even if it's a really, really complicated function, it'll always have this property that you just flip every input-output pair, and that's your inverse function. So it's really, really simple. Just reverse the table. Table entries. And that's always the relationship between f and f inverse. Now, if that's the case, when you take an inverse function, all you're doing is swapping the x and the y coordinates. And that's also similar to, remember when we looked at these 3 steps. Interchange x and y. Every time you see a y, you write an x. Every time you see an x, write a y. That is the same as interchanging the 2 columns. Put what was in the x column in the y column. Put what was in the y column in the x column. That's the same as this. Okay. Now, when you look at graphs, what does it do to something when you have interchanged the x and the y? Let's look at the graph. So let's take this one. This. Okay. Now the first points for function f, 1 over 3 up. 2 over 6 up. 3 over 9 up. You get those 3 points. And they lie on a line like this. Okay, now let's look at over here. The point 1, 3, 1 over 3 up, becomes the point 3, 1. And let me show you what will happen. This 45-degree angle line is the line y equals x. What we're going to be doing is we're going to be reflecting across the line y equals x. We're going to take this point, we're going to draw a line perpendicular to this point, to the black dotted line. We're going to go exactly in the same direction, that same distance in the other direction, and we'll end up right over here. Alright, this is the point 3, 1. When you change the x and the y coordinates, you reflect across the line y equals x. Let me show you with the next point. 2 over 6 up. If I draw a line perpendicular to the black line, keep going in that same direction, whoops, over here, I will get to the point 6 over 2 up. And what we say is that these points down here are the images of this point under the reflection. We reflect across this and we get to the image point. We take this one, we reflect across this, and we'll get to the image point, which is 9 over 3 up. So a line through, perpendicular to this, through would take us to that point right here. Alright, and what happens is whenever you have a function let me give you any old function x, y. If I have a function that does this, let me fix it up a little bit. Then the new function so this one is y equals f of x. The new function will be the same function reflected across the line y equals x. Like this. This is y equals f inverse of x. And notice any one of these points, if you went perpendicular to this, same distance over here, would reflect to its image point over here. And it's as if you folded your paper along this black dotted line, and this was wet ink, and then what shows up on the wet ink on the other half of the paper is your inverse function. This is how two functions that are inverses will look. One is a reflection of the other across the line y equals x. Alright, and then One-to-one functions. A brief statement. They pass a horizontal line test. Okay. Remember the vertical line test for functions? Well, to be a one-to-one function, you have to pass a horizontal line test. And super briefly, as well, we're out of time. I'll have to get back to this next time. All right, so the homework is 3.7. And it says in the schedule for today, it says start the take-home portion of exam 1. And so a week from today is exam 1. And you should be going to the take-home portion. So let me go show you student view. All right. Go into Canvas modules. All right, and then inverse functions. Towards the bottom of the inverse functions, we see demonstrate take-home portion of exam 1. And so this is due for spot check the next time that we meet, October 6th. And if you click on it, it talks about it, and if you click on this, it says the take-home portion, you can download it, and so on. Notice it even has answers here. So, do the problems without looking at the answers. Do it as if it's a real test. And then afterwards, check your answers and kind of grade yourself. And then it'll tell you, this is what I really need to work on. And then here's the exam. The exam will be on next Thursday the 8th. If you click on this now, it will just tell you it's locked until 1:15 p.m. on the 8th. And we'll have a 1 hour to do it from 1:15 to 2:15 p.m. So class will run short next week. We'll do a little bit at the beginning of class. I'll explain a new section. And then you're going to take the exam and the second part, the hour from 1:15 to 2:15. Any questions? All right. I will see you all Tuesday, and have a good weekend.
Bye, thank you.
You're very welcome.